Group 3 from Math 5670. My name is Wen Yang. I'm a graduate student in actual science. And his name is Yelian Yuan. And his name is Yingfa Xie. They are both graduate students in the Applied Financial Math major. And we are going to talk about our final project. Yeah. Okay.
So today we will talk about Australia credit card approval. As we all know, commercial banks receive a lot of applications for credit cards. Many of them get rejected for many reasons, like high loan balances, low income levels, or too many inquiries on their reports. Manually analyzing these applications is mandated, error-prone, and time-consuming. So this project is trying to find a way to build a model that can automatically analyze those credit cards applications. This project is to create a model to classify credit card applications. We need to predict the result that applicants will pass the credit card application or not. The digital number 1 stands the applicant successfully passes the credit card application process, and 0 means the applicant fails. We can see from the below screenshot, the data provided contains 6 numerical attributes and 8 categorical attributes. All attribute names and values have been changed to meaningless symbols to protect confidentiality of the data. This data set is good for practice purpose with continuous as well as nominal attributes. There are also a few missing values. So the first part is data exploration. For training the model, we need to import the training data. In this project, we use the functions in package pandas to read the Excel file. After we read the Excel file, we found there is a column of data that's called unnamed, which is a kind of useless data. So we could know from the website that only 14 features in the data set, so we need to delete it from our data frame. To delete the features, we could use the function difference, and we can get the data frame like that. In fact, before we got the data set have been processed, so we don't have to delete other data or other features in this step. And we got the training features. The other data set we need to get is the training label. We use the same method like before, and the data frame we got is like this.
In order to let the features change in the similar range, we should do some normalization to the dataset. Here we talk about 2 kinds of normalization in the package of scikit-learn. Min-max scalar rescale the dataset, let all feature values in the range from 0 to 1. Standard scalar removes the mean and scales the data to unit variance. In this project, we use the min-max scalar because it achieves better accuracy. After scale the data, we are going to split them into 2 datasets. One of them is called train dataset, and the other one is called test data. We use the train dataset to train our model and use the test set to test our model. In this project, we use the function train test split from the package scikit-learn. Usually, we could set the split ratio as 7 to 3. But in this project, we set it as 9 to 1 because we want more data to train the model. If you found that after splitting into 2 datasets, the examples are unbalanced, For example, your test data have too much 1 and little of 0, or your test data have too much 0 and little of 1. It might affect the performance of the model. In this case, we could use the function smooth from the embolden. By using the function, it will generate some samples and let the dataset have similar positive example and negative example, which is called oversampling. But in this project, we don't have to do this because the data is good enough.
Okay. So in this project, we use two different methods to build the model. Firstly, we use the function write by ourselves, and the second method is to use the building function to build the model. So in order to build the model, we try to use the idea of deep learning and neural network. In this project, as we can see in the PowerPoint, we have 3 layers. The first one is input layers, and there are 14 nodes in there because there are 14 attributes in our project. And we only have one hidden layer in this project with 12 nodes. But why we choose the 12 nodes is just because we try the different number of nodes to find the better result. After we define the number of the layer and the number of the nodes in each layer, we initialize the theta, which is the weight of the different feature. Because we have more than one layer in this model, we use a dictionary to save all the theta. So when we finished all the initialization, we could get our value of the output in forward propagation. And now we could calculate the cost using the cost function. If we want to predict more accurate value, we need to minimize the value of the cost function, which means we need to modify the theta according to the gradient of the cost function. If we modify our theta along with the way of gradient descent, we should get value of the cost function smaller, which means that the predict value is more close to the true value. In optimization, we will set a number called maximum iteration step, which means how many times we will modify the theta in our model. In this function, we just call the function we defined before and train the model. Finally, we return the theta after training. If we print out the cost, it should always decrease into convergence. After we got our theta in the model, we could see them to test the data that we split out before. And we calculate the accuracy, which is close to 93%. In fact, we just split a small part of the data into the test data, and it might be a reason that we could get high accuracy. Now we could use our model to predict the test data. Like before, we imported the data from the Excel and did the same process to the data. And we use our model to predict the approval of the credit card case. And we got the result, and we uploaded to the website and get the score about 86%. And we use another method. In this method, we use a building function from the package sklearn.neural network. And we set only one hidden layer with 20 nodes. We imported and trained the data we got before and fit into the model. Using the model, we got the score of the test data we split it before, which is 83%. Also, we use the model to predict the test Excel file and write the result into Excel. We submit it to the website and we get the score around 84%. Okay. Yeah, thanks for watching.